Physical chemistry. We will use isothermal titration calorimetry raw heats to fit a 1-to-1 binding model and estimate Kd, delta H, delta S, and delta Cp. First, a quick picture of the instrument and the raw power trace. Then, we integrate the peaks to get heats per injection. Next, we write the 1-to-1 binding model and overlay a fit. Finally, we extract thermodynamics and demonstrate estimation of delta Cp. The calorimeter integrates the power peaks to yield the heat released in each injection. On an exothermic binding, each bar is typically negative heat in microcalories. We also track the molar ratio of ligand to macromolecule as the titration proceeds. The 1-to-1 binding model connects concentration to heat. At each step, the total concentrations in the cell are updated by dilution and injection. The complex concentration is given by the quadratic solution. The total heat in the cell equals cell volume times delta H times the complex. The heat of injection is the stepwise difference. We then fit Kd and delta H by minimizing residuals between measured and model heats. Here is a clean way to visualize the fit: heats per injection versus molar ratio. The red points are the data. The blue curve is the 1-to-1 model. Below, we show residuals, data minus model. Smaller, structureless residuals indicate a good fit and sound model choice. From the fit, we read Kd and delta H. At temperature T, delta G equals minus our T times natural log of the association constant, and equals delta H minus T delta S. So delta S equals delta H minus delta G all over T. Here are the numerical values at 298 Kelvin. To estimate delta Cp, we examine how delta H changes with temperature. The slope of delta H versus temperature is delta Cp. Here is a small example with 3 temperatures and a best fit line. Summary. 1. Integrate raw power to heats per injection. 2. Fit 1-to-1 binding model to estimate Kd and delta H. 3. Compute delta S from delta G equals delta H minus T delta S. 4. Estimate delta Cp from the slope of delta H versus temperature.